Complexity. Patterns can evolve over time, resulting in outcomes that are radically different from their origins. In evolution, an organism may appear identical from one generation to the next, but over millions of years and billions of generations, it can change dramatically, eventually sharing no visual features with its earliest ancestors. Through this process, every human being can be traced back to a reptile-like furry rodent, then to a fish, and ultimately to a single-celled bacterium. This process of evolution, the transformation of patterns over time, is not limited to biological life, but can also be generalized to technological development and cultural evolution. Firearms, airplanes, smartphones, automobiles, computers, language and institutions, whether military or educational, have all evolved and reached greater levels of complexity over time. Evolution is a universal process. All technological innovations operate under an evolutionary process. The same forces that lead to biological complexity, natural selection, competition, random mutation, and viral infections, have comparable analogs in the technological and cultural domains. For example, in the storage, duplication, sharing, and creation of information, the phenomenon of sexual reproduction can be compared to the invention of the printing press and the Internet. Soon after the emergence of each of these phenomena, sexual reproduction, the printing press, and the Internet, a revolution in complexity follows. What is the alternative? What happens if we continue to deny the universality of evolution and limit it to biology alone? The answer is simple. We will remain ignorant of the universal forces that drive technological innovation. We will be uninspired. We will continue to see biology as isolated, even though evolution has produced organisms that can fly, engineer, and think. We will remain blind. Nothing occurs in a vacuum, and technological innovation is no exception. The forces that enable evolution to produce the human brain and human beings are the same forces that drive technological innovation. There is no isolation. Scientists and engineers do not work alone. Institutions and infrastructures facilitate the communication of information from one scientist or engineer to another, allowing progress to be copied, combined, experimented with, and improved upon. Similarly, individual organisms do not operate in isolation. Through sexual reproduction and genetics, traits are shared, tested, and subjected to natural selection within populations, enabling species to evolve and reach greater levels of complexity. Complexity to what ends? We know that a Tesla electric vehicle is more complex than the Ford Model T. We know that a slim LED TV is far more complex than a bulky cathode ray tube. We observe that in any technology, the modern version is more complex than its predecessor. Given two entities of the same lineage, we can consistently determine which is more complex. But what exactly does it mean for an entity to be more complex? More specifically, what does it mean for a pattern to increase in complexity? A universal definition is needed. For a patternist, complexity is the quantity of patterns utilized by an entity. The more patterns an entity possesses, uses, and exploits, the more complex the entity comparatively becomes. Patterns build upon patterns. Complexity builds upon complexity. Each solution to a problem becomes a new pattern ready to be exploited, sparking further adaptation and innovation in an endless cycle. The venom of a scorpion becomes more potent. A cheetah grows faster. Tanks and airplanes become deadlier. Bombs become more destructive. There is no isolation. The environment will always contain a multitude of intelligent systems. Intelligence is the ability to find and exploit patterns. When intelligent systems compete, they drive each other toward ever higher levels of complexity in a perpetual arms race. Intelligent systems exploit, challenge, and adapt to one another. One system attacks, another builds defenses, prompting attackers to refine their strategies while defenders enhance their resistance. Each advantage compels the other to innovate, counter, and seek the upper hand. This dynamic accelerates both evolution and innovation, deepening each system's complexity as they push each other toward new solutions and adaptations. Through this relentless interplay, intelligent systems, whether biological or technological, fuel ever greater complexity. Each iteration builds on the last, layering solutions upon solutions, patterns upon patterns. The direction of technological evolution is undeniably toward increasing complexity, as is biological evolution. A lineage of biological phenomena can be traced by increasing complexity, from prokaryotes to eukaryotes, to sexual reproduction, to multicellular life, to organisms with nervous systems, to adaptive brains, to human beings and beyond to science, engineering, and artificial intelligence. Although the basic forces underlying evolution that generate variation may be random, the selective pressures of merely maintaining existence in a physically demanding universe drive evolution to develop patterns of greater complexity. Unfortunately, current theories of evolution cannot fully explain the increasing complexity of biological life, let alone connect it to the innovation observed in technology. Patternism provides an answer. Patternism not only explains evolution's trend toward greater complexity from first principles, but also predicts its ultimate goal. From our understanding of patterns, we see that reproduction is the act of self-propagating patterns. To adapt is to make use of patterns found in the environment. To predict, to deceive, and to eat are all acts of pattern utilization. Given the utility of patterns, it follows that all organisms must find and use patterns to survive in a demanding universe. Thus, organisms must develop the ability to find and utilize patterns. Evolution's goal, therefore, is to develop faster and more efficient ways to find and use patterns. Genes store patterns across generations. Sexual reproduction enhances this by allowing patterns to be shared and combined within populations. The development of the nervous system and the storage of patterns within neurons allow patterns to be found and utilized within a single lifetime. The invention of language allows patterns to be stored outside the individual and within culture. The invention of writing and the printing press accelerated this, as did the Internet, which has expanded the speed and breadth of pattern sharing yet again. The current pursuit of artificial intelligence aims to create systems that find, recognize, and store patterns, allowing these systems to be mass-produced and put to work without complaint. For a patternist, the ability to find and utilize patterns is intelligence. As a result, evolution seeks to create faster and greater levels of intelligence. It must be emphasized that, although patternism describes evolution as having goals, the drive toward greater intelligence is not due to any intentional agency within evolution, but rather to the natural process of elimination. Among all variations generated, those that help identify and exploit patterns will outlast and outcompete those that do not. Human beings did not consciously decide to understand intelligence. The belief that we chose to understand intelligence, find a theory, and replicate it in machines is a lie. Our pursuit of understanding intelligence, of knowing what we are, has always been driven by the unconscious forces of a universe that is dominated by the utility of patterns. We human beings are merely the result of, and just a step in, the process of pattern searching for patterns.